In this video, we're going to talk about percent yield calculations. Now, with percent yields, all we have to do new is a percentage calculation. There's no new chemistry calculations. Two terms we got to talk about: theoretical yield. Theoretical yield, we actually know how to do this, and we're actually doing this calculation already. The theoretical yield is the maximum amount of product that could be produced. It's what theoretically should happen. Okay, the hypothetical amount. Here's the good thing. This is what we've been solving for all along. All the stuff from section 3, section 7, section 3 there, all of 9.1 and 9.2, all that stuff has all been theoretical yield. That's what the book tells us it should be. Okay? So, nothing new there. Been doing that all along. Actual yield, that's reality. This is what we would do if we actually went back into the lab and measured these chemicals. At some point, we'll be doing the silver lab. There's a couple other limiting reactant labs that we'll do, and we're going to compare what the book tells us, which is theoretical, with what actually happens in the lab, because this is what did happen once the reaction was completed. And then percent yield is just giving us a percent representation of how much we did make compared to how much we should have made. Okay, so to do the actual calculation, all we're going to do is take a percentage of what we should have produced compared to what we actually did produce. Simply AY divided by TY times 100. Now, when we do a calculation like this, here's how the setup will be. We're going to be given either the percent or the actual yield. We have to be given one of those because we're actually not going to be able to go to the lab and do the lab. So the problem will tell us one or the other. They're going to want us to solve for that opposite one that wasn't given. Now the third piece, this is what we'll have to do, is you're still going to have to solve theoretical yield. That's part of the way we're working through these problems. You need to figure out what should be made. So we're going to be doing those A to B problems from section 2. So it's just two pieces. One, you're going to have to do what we did in section 2 no matter what, because that's what's telling us what should happen. Then, based upon the information you're given, you're going to figure out, well, what's percentage? Did I make 80%, 90%, 20%, or how much? Am I going to make 5 grams or 10 grams or 2 grams? Okay. So, on page 317, there's a sample problem dealing with chlorobenzene and chlorine gas. Okay? And it's simply, if we read the question, it says when 36.8 grams of C6H6, which is benzene, reacts with excess chlorine gas, the actual yield is 38.8. What is the percent yield? So here's the first nice thing. We don't have to worry about limiting and excess reactants because it already tells us that. It tells us in the lab what actually happened. What we need to figure out, okay, is the theoretical yield, because percent yield is equal to actual over theoretical times 100. And what's theoretical? That's doing our A to B problems. So we're going to go from 36.8 grams of C6H6 to grams of C6H5Cl. And that answer is going to be our theoretical yield that we plug up in there. And you can see on 317 how they've worked through that problem. Got two show-me's here. Practice problem 1 and 2 on page 318. In the first one, they want to find percent yield. So we start out with a mass of carbon monoxide. They tell us in a lab 68.4 grams are made. What percentage is produced? Practice problem 2, we're given an amount of aluminum, and we're finding out that the amount of copper that's produced is 56.6%. So we're trying to find out what is the actual amount of copper produced. We're only going to make 56.6% of what we should. In both cases, we need to know the theoretical yield. We need to know Ty here, and we need to know Ty for copper. Nothing new, because that's the A to B problems that we're doing in 9.2. So again, both of these are show me, and that kind of covers percent yield and actual yield.